Hello friends, in this video we will look at the crux of the branch and bound method. This is another design technique in algorithm design subject, and in the previous videos we have looked at the dynamic programming control abstraction, and we have looked at the backtracking method, and today we will look at the branch and bound method. In branch and bound, what we do is we study all the alternatives and we will take one decision at a time and we will select the optimal decision for expansion. If you remember, in dynamic programming, we develop a tree with selecting one item and not selecting the same item, and we develop a binary tree. So this method is an extension of that. So let us look at one example. So let us take the 0-1 knapsack problem, which we have already looked at in the dynamic programming, and now we will look at it using the branch and bound method. So the example that I am using for knapsack, I have 4 elements with me and the capacity of the bag is 15. The profits are 10, 10, 12, 18 for different items, and the weights are 2, 4, 6 and 9. Now in branch and bound, I will be taking 2 measures. There is a bound which will take all items fully plus the partial item in the end, and there is a U bound which will take only full items, no partial items are included. So there is an upper bound and there is a bound. 2 values I am going to calculate. So first of all, at the first level, I don't have any choices, any decision, any bound or U-bound value. So what I will do, I will generate for item 1 whether it is taken and it is not taken. So when I will include the first item, I will calculate if I include first item, second full, third full and partial whatever can be included, and then first item full, second item full, third item full and the partial not included. So this is the U-bound and this is the bound. So in this I do not have any prior information what items I have to select. I am just selecting first is mandatory, remaining what all can fit into the bag. I am taking them in the same order. Similarly, for not taken, the first item is not included and the remaining items can be included into the bag in the decreasing order of weight and increasing order of profits. So I will include the not taking the first item and taking the first item. So this is going to generate the bound and the U-bound. So when I compare the partial value with the full value and the U-bound of this value, I find that this particular node is giving me the minimum values. I have negated all the values that I am calculating. This is the total profit. So 38 was the profit. So I have minimized it. That means I have multiplied the total profit with -1. So this particular node is giving me the minimum value. So now I will select this node and expand this further and keep this node for later consideration. Now when I expand this further, now again for item 2 I have 2 choices. Item 2 is included, item 2 is not included. So when item 2 is included, so since this node in the first node itself we have calculated for considering the second item, so the same values will be copied from the parent node. And if we don't take the second item, then the choices are first is taken full, third is taken full and fourth is taken in some fraction, and or only first and third are taken and fraction is not considered. Now we compare this bound and U-bound with this bound and U-bound, and since this is giving the minimum values, so we expand it further. For the third item, included and not included. So when we include the third item, we will copy the same values as that of the parent. And when the third item is not included, the fourth item is included in full. So here by chance the bound and the U-bound both are same. Now when we compare this with this value, we see that the bound is coming out to be same in both the cases, but the U-bound is different. This one is giving minimum U-bound with -38 and this one is giving -32. So this is minimum, so we will expand this further. So we will consider fourth item taken fully or not taken. So since this is the branch of first item taken, second item taken, third item not taken, so it is 1, 2, 4 or 1 and 2 if fourth item is not taken. So only these two choices are there. So out of these two, this one is giving the minimum value of minus 38. So this particular node will get selected. So in this way, like dynamic programming, we are generating a binary tree where we are making decision for each item whether to include that item or not, and then whichever node is going to give us the least cost or the best profit, we will be selecting that node. So I hope this video is useful to you and you have understood the branch and bound method. So thank you.